Series notation.
So how do you write series in sigma notation? So here's our first example, number 1. So the given is 2n plus 1, and the upper limit is 4, so we need first 4 terms, and the lower limit equals n equals 1, so the value of n is equals 1. So in finding the first 4 terms, we need to use the given 2n plus 1. So since the value of n is equals 1, so we need to substitute 2 1 plus 1 equals 3, 2 2 plus 1 equals 5, 2 3 plus 1 equals 7, 2 4 plus 1 equals 9. So add it. So the answer is 24. So here's the second example of writing the series notation. So the given is x squared and the upper limit is x equals 5, so we need the first 5 terms, and the lower limit is x equals 1. Then in finding the first 5 terms, we need to use the given x squared. Since the value of x is equals 1, so we need to substitute. So 1 squared equals 1, then 2 squared is equals 4, then 3 squared is equals 9, then 4 squared is equals 16, and 5 squared is equals 25. Then add it. The answer is 55. That's all. Thank you.
Hi guys, this is Eliza. In this example, what I'm gonna do is evaluate trigonometric functions. So let's just kind of follow through my step-by-step process here. My step-by-step is going to be, first, just sketch the angle. So by sketching the angle, we understand that the half of a circle is pi. In terms of right denominator, that's 3 pi over 3. So I need to look all the way around circle, which would be 2 pi, which is same thing as 6 pi over 3. So obviously, this angle is bigger than that. So we can see that we are almost there. We are going to be 3 pi short.
Give a point in the terminal sides of -3 and -7, set all the 6 trigo function. We are talking about the angle on the standard position. So we are going to be using our sign and we draw an angle on the standard position. So -x and -7, that is quadrant 3. Now I am going to set up the reference triangle and that allow us to work on our trigo function. And I am also going to put those value among the x and y value just to make sure not that we not forget the sign and when I go to set up my trigo function. Now I have a right triangle and it is a reference triangle because it is going to x-axis and that is making of member degrees between the terminal sides and the x-axis. Now, so a little Pythagorean theorem, that is 3 squared plus 7 squared equals r squared. 3 squared is equal to 6 plus 7 squared is equal to 14 equals r squared. We need to add 6 plus 14 is square root of 20. Sine of theta is y over r, so it's -7 over square root of 20. We need to rationalize that by multiplying the top and bottom by the square root of 20 and we get -7 times square root of 20 over 20. And the cosine is x over y, so it's -3 over square root of 20 and when you rationalize that we get -3 square root of 20 over 20. Remember that the sine is y over r and the cosine is x over r, and quadrant 3, those x and y value are negative. So make sure the answer is both negative. And tangent of theta is y over x, so it's negative 7 over negative 3. So, and the reciprocal of sine is cosine of theta is going to, with this value flipped, so it's going negative 20 over negative 7. And the second is, we're gonna flip negative square root of 20 over 3. And the cotangent is, we're gonna flip negative 3 over negative 7. So we have all evaluate all 6 trigo function in exactly form. There are no rounded decimal anywhere. We have evaluate and found the exactly value of 6 different trigo function. We just had to know the point of the terminal side of the standard position angle. Where can we find hypotenuse? Where we find hypotenuse using Pythagorean theorem. So, hypotenuse is going to equal square root of opposite side is 5 squared, and the adjacent side is 7 squared. 7 squared is equal to 21, plus 5 squared is equal to 15. 21 plus 15 is 36. 36, the square root of 36 is 6. So that we find our hypotenuse, we need to move forward in the function value. So the function value of the sine of the theta is going to equal to the opposite over hypotenuse, that is 5 over 6. And the cosine of the theta is adjacent over the hypotenuse, is 7 over 6. And the tangent of the theta is going to opposite over adjacent, that is 5 over 7. For the reciprocal function, I got the cosecant of the theta of the sine is 6 over 5. And the secant, there's a reciprocal of the cosine, that is 6 over 7. And the cotangent of the reciprocal of the tangent is 7 over 5. That's all. Hi guys, how to solve trigonometric function. Give the point 7 and 5 on the terminal side. So I draw a simple graph where there's an x-axis and the y-axis. So I connect the straight line down to the origin, and the second is the vertical line on the x-axis. So that I create as the origin has an angle. So we can see this one, we can call this one. We can say that the side opposite of the theta has a length of 5, and the adjacent this has a length of 7. So I was so wondering if I want to find hypotenuse.